Welcome to the Daily Recap. Robots can now watch you do something once and then figure out how to do it themselves. No programming, no engineer typing in thousands of lines of code. Just a robot, watching, learning, deciding. So here is the question you need to sit with today. What happens when we stop telling machines what to do and just let them figure it out on their own? Researchers at Carnegie Mellon University and a team affiliated with MIT published findings in early 2025, describing a new framework that allows robots to observe human behavior and independently learn complex physical tasks without being explicitly programmed to perform them. The system uses what scientists are calling a form of self-awareness, meaning the robot can model its own body, understand its own limitations, and then adapt what it watched a human do into something it can actually execute. Here is what makes this different from what we have seen before. Previous systems required enormous data sets. You had to show a robot the same motion thousands of times under controlled conditions. This new approach requires far fewer demonstrations. In some tests, a robot watched a human perform a task just 3 to 5 times before successfully replicating it and then modifying the technique when obstacles or changes were introduced. The tasks involved were not simple. We are talking about things like sorting irregularly shaped objects, folding laundry, and assembling multi-part components. Tasks that even older AI-assisted robots struggled with because they involve constant, real-time judgment calls. The team used a combination of large vision models, physical simulation environments, and reinforcement learning loops that allowed the robot to essentially rehearse internally before attempting the real thing. Dr. Deepak Pathak at Carnegie Mellon, who has been a leading voice in this area of robotics research, described the system as a step toward robots that can be genuinely generalist. Not a machine built for one job on one factory floor, a machine that can walk into a new environment and figure things out. Okay, so why should you care? Let me be direct. This is not a lab curiosity. This is the thing that changes how the next decade of work actually looks for millions of people. Think about what this technology is aiming to replace or assist with. Home care for the elderly, warehouse logistics, hospital supply chain work, construction assistance. Right now, deploying a robot in any of those environments requires expensive custom engineering. Every new task needs new code. That is why robotics has stayed mostly in places like car manufacturing, where the job never changes. This breakthrough chips away at that wall. For everyday people, the most immediate impact hits the labor market. There are roughly 1.7 million warehouse and fulfillment jobs in the United States alone. Companies like Amazon have already invested billions into robotic automation. But they have been bottlenecked by exactly the problem this research addresses: robots that cannot adapt. If that bottleneck breaks open, those jobs look very different very fast. On the positive side, imagine what this means for elder care. The United States will have over 80 million people aged 65 and older by 2040. There are not enough caregivers. A robot that can watch a nurse perform a task and then assist with that task independently could be an enormous help to families who cannot afford round-the-clock human care. But experts are raising serious flags right alongside the excitement. Dr. Stuart Russell at UC Berkeley, one of the most respected voices in AI safety, has been consistent in warning that systems which learn autonomously need robust oversight mechanisms. The concern is not that the robot goes rogue in a movie villain way. The concern is subtler. A robot that teaches itself can optimize for outcomes in ways its designers never anticipated. It might learn a shortcut that works most of the time, but fails in edge cases. In a warehouse, that is a broken package. In a hospital or a home, that is something much worse. There is also the accountability question. When a human makes a mistake, we know who to hold responsible. When a self-learning robot makes a mistake based on behavior it taught itself by watching humans, the chain of responsibility gets murky fast. To understand why this moment matters, you have to understand how long robotics has been stuck. The field has been promising a revolution for decades. The Roomba came out in 2002, and it felt like the future. Boston Dynamics has been releasing jaw-dropping videos of robots doing backflips since the 2010s. But actual useful deployment in unstructured environments, meaning anywhere that is not a perfectly controlled factory, has been painfully slow. The core problem has always been generalization. Narrow AI is brilliant. You can train a system to beat the world chess champion, or identify tumors in an MRI with superhuman accuracy. But the moment you ask that same system to do something even slightly outside its training, it collapses. Robots have had the same issue physically. Great at one thing, helpless at everything else. The wave of large language models starting around 2022, with GPT-4 and accelerating through 2023 and 2024, changed the underlying intelligence layer. Suddenly, robots could be paired with systems that understood context, language, and visual input at a much higher level. Companies like Figure AI, Physical Intelligence, and Google DeepMind all launched robotics divisions or dramatically expanded them between 2023 and 2024. The research published in 2025 is a direct product of that accelerating foundation. So where does this go from here? In the short term, expect to see this technology move toward controlled commercial environments first. Warehouses, factories, and logistics hubs are the most likely early adopters because the stakes of a mistake are lower and the economic incentive is massive. Within 2 to 3 years, robotics analysts at firms like RK Invest project that self-adapting robotic systems could begin entering elder care facilities and hospital settings in pilot programs, particularly in Japan and South Korea, where labor shortages are already severe. The regulatory picture is the wild card. The European Union has already drafted provisions in its AI Act that touch on autonomous systems, but physical robotics that learns independently is a category that existing frameworks were not really built for.